161 is another finding from TaylorBit's audit of advanced blockchain, where the concern was about insufficient testing. The repositories under review lacked appropriate testing, which increased the likelihood of errors in the development process and made code more difficult to review. The recommendation was to ensure that unit tests cover all public functions at least once, as well as all known corner cases, and also to integrate coverage analysis tools into the development process and regularly review the coverage. This is related to broad aspect of testing in 155 that we discussed in Security Pitfalls and Best Practices 201 module. 162 is another finding from TaylorBit's audit of advanced blockchain, where the concern was about project dependencies containing vulnerabilities. Yarn audit identified off-chain dependencies with known vulnerabilities, and due to the sensitivity of the deployment code and its environment, it was important to ensure that dependencies were not malicious. The recommendation was to ensure that dependencies were tracked, verified, patched, and audited. This is related to the broad aspects of configuration in 165, external interaction in 180, and dependency of 183 that we discussed in Security Pitfalls and Best Practices 201 module. 163 is another finding from TaylorBit's audit of advanced blockchain, where the concern was about the code base lacking code documentation, high-level descriptions, and examples, making the contracts difficult to review and increasing the likelihood of user mistakes. The recommendation was to review and properly document the code base and also consider writing a formal specification of the protocol. This is related to broader aspects of system specification and documentation in 136 and 137, and the principle of psychological acceptability in 199 that we discussed in Security Pitfalls and Best Practices 201 module. 164 is another finding from TaylorBit's audit of advanced blockchain, where the concern was about ABI encoder v2 not being production ready at the time of this audit, given that more than 3% of all GitHub issues for the Solidity compiler were related to experimental features, primarily ABI encoder v2. ABI encoder v2 had been associated with more than 20 high-severity bugs at that point in time. The recommendation was to not use ABI encoder v2 by refactoring the code such that structs do not need to be passed to or returned from functions, which is a feature enabled by it. This is related to compiler bugs in 77 to 94 of Solidity 101 module and dependency issues in 183 of Security Pitfalls and Best Practices 201 module. 165 is a finding from TaylorBit's audit of deforce lending protocol, where the concern was about the contract owner having too many privileges compared to standard users of the protocol. Users could lose all of their assets if a contract owner's private key were to be compromised. The contract owner could, for example, do the following. 1. Upgrade the system's implementation to steal funds. 2. Upgrade the token's implementation to act maliciously. 3. Increase the amount of I tokens for reward distribution to such an extent that rewards could not be disbursed. And 4. Arbitrarily update the interest model contracts. Such concentration of privileges created a single point of failure and increased the likelihood that the owner would be targeted by an attacker, especially given the insufficient protection on sensitive owner private keys. Additionally, it incentivized the owner to act maliciously. So the recommendations were: 1. Clearly document the functions and implementations the owner could change. 2. Split privileges to ensure that no one address had excessive ownership of the system. 3. Document the risks associated with privileged users and single points of failure. And 4. Ensure that users were aware of all the risks associated with the system. This is related to access control and trust issues we discussed in 148, 149, 160 and 172, and principle of least privilege in 192 and principle of separation of privilege in 193 of Security Pitfalls and Best Practices 201 module. 166 is another finding from TrailorBit's audit of D4's lending protocol, where the concern was about poor error handling practices in the test suite. For context, the test suite did not properly test expected behavior, and certain components lacked error handling methods which would cause failed tests to be overlooked. For example, errors were silenced with a try-catch statement, which meant that there was no guarantee that a call had reverted for the right reason. As a result, if the test suite passed, it would have provided no guarantee that the transaction call had reverted correctly. The recommendation was to test operations against a specific error message, ensure that errors were never silenced to check that a contract call had reverted for the right reason, and overall follow standard testing best practices for smart contracts to minimize the number of issues during development. This is related to the broad aspect of testing in 155 of Security Pitfalls and Best Practices 201 module. 167 is a finding from Sigma Prime's audit of Synthetics Ether Collateral Protocol, where the concern was about redundant and unused code. For example, the record loan closure function returned a boolean which was never used by the calling function, and there were also some if statements that were redundant and unnecessary. So the recommendation was to remove such redundant constructs or use them in meaningful ways. This is related to redundant constructs in 157 of Security Pitfalls and Best Practices 201 module. 168 is another finding from Sigma Prime's audit of Synthetics Ether Collateral Protocol, where the concern was that a single account could capture all the supply in the protocol. For context, the protocol did not rely on a max loan size to limit the amount of ETH that can be locked for a loan. As a result, a single account could issue a loan that could reach the total minting supply. The recommendation was to make sure that this behavior was understood and documented, and also consider introducing and enforcing a cap on the size of the loans allowed to be opened. This is related to ETH handling in 158, data validation in 169, and numerical and accounting issues in 170 and 171 of Security Pitfalls and Best Practices 201 module. 169 is another finding from Sigma Prime's audit of Synthetics Ether Collateral Protocol, where the concern was about insufficient input validation, specifically in that the Ether Collateral constructor did not check the validity of the addresses and other types provided as input parameters. This, for example, made it possible to deploy an instance of the contract with critical addresses set to 0. The recommendation was to consider introducing required statements to perform adequate input validation. This is related to missing zero address validation in 49 of Security Pitfalls and Best Practices 101 module, and broader aspects of function parameters in 138, function invocation arguments in 149, and data validation issues in 169 of Security Pitfalls and Best Practices 201. 170 is another finding from Sigma Prime's audit of Synthetics Ether Collateral Protocol, where the concern was about unused event logs, in that log events were declared but never emitted. The recommendation was to emit these events where required appropriately or remove them entirely. This is related to unused constructs in 156 and auditing and logging in 173 of Security Pitfalls and Best Practices 201 module. 171 is a finding from Sigma Prime's audit of InfiniGold, where the concern was about unintentional token burning in transfer from. For context, InfiniGold allowed users to convert their PMGT tokens to gold certificates, which were digital artifacts effectively redeemable for actual gold. To do so, users were supposed to send their PMGT tokens to a specific burn address. However, the transfer from function did not check its toAddress parameter against this burn address, which would allow users to accidentally send their tokens to the special burn address using the transfer from function without triggering the emission of the burn event, which dictated how the gold certificates were created and distributed. So effectively, users would lose their tokens without redeeming them for gold certificates. The recommendation was to prevent sending tokens to the burn address in the transfer from function by adding a require within transfer from, which disallowed the toAddress to be the burn address. This is generally related to missing zero address validation in 49 of Security Pitfalls and Best Practices 101 module, and broader aspects of function parameters in 138, function invocation arguments in 146, data validation in 169, accounting issues in 171, and error reporting issues in 175 of Security Pitfalls and Best Practices 201 module. 172 is another finding from Sigma Prime's audit of Infinigold, where the concern was about denial of service from unbounded lists. For context, the reset function reset the role linked list by deleting all its elements. Calling the reset function would exceed the block gas limit, 8 million at the time of the audit, for more than 371 total elements in the role linked list. Similarly, other functions also looped through linked lists, which meant that certain protocol actors could perform denial of service attacks on the lists they administered. The recommendation was 1. Either check that the linked list size is strictly less than 371 elements before adding a new element, or 2. Use the gas left solidity primitive to make sure that traversing the linked list did not exceed the block gas limit at any point, or 3. Change reset to take a specific number of elements as a function parameter. This is related to the gas impact on DOS in 42, 43 and 44 of Security Pitfalls and Best Practices 101 module, and broader aspects of denial of service in 176 and gas issues in 182 of Security Pitfalls and Best Practices 201 module. 173 is another finding from Sigma Prime's audit of Infinigold, where the concern was about the ERC20 approve function being vulnerable to front running. The recommendation was to be aware of front running issues in approve and potentially use OpenZeppelin's library with increase allowance and decrease allowance functions, with the caveat that deviating from the ERC20 standard to address this issue could lead to backward incompatibilities with external third-party software. This is related to transaction order dependence in 21 and ERC20 approved race condition in 22 of Security Pitfalls and Best Practices 101 module, along with ERC20 approved race condition in 105 and broader aspects of timing issues in 177 of Security Pitfalls and Best Practices 201 module. 174 is another finding from Sigma Prime's audit of Infinigold, where the concern was about an unnecessary require statement in blacklistable contract, which implemented a zero address check on the toAddress when this check was also implemented in the transfer function of ERC20 contract. The recommendation was to consider removing the require statement for gas saving purposes. This is related to redundant constructs in 157 of Security Pitfalls and Best Practices 201 module. 175 is another finding from Sigma Prime's audit of Infinigold, where the concern was about the reward rate rounding to zero if duration was greater than reward. The reward rate value was calculated as reward divided by duration. And due to the integer representation of these variables, if duration were to be larger than reward, the value of reward rate would round down to 0. Thus, stakers would not receive any reward for their stakes, and there would be other implications as well, such as collection of dust tokens. So the recommendation was to be aware of this rounding issue and also consider providing a way to claim the dust SNX rewards from rounding. This is generally related to divide before multiply in number 20 of Security Pitfalls and Best Practices 101 module, and broadly related to data validation and numerical issues in 169 and 170 of Security Pitfalls and Best Practices 201 module. 176 is another finding from Sigma Prime's audit of Infinigold, where the concern was about event log poisoning. For context, calling the withdraw function would emit the withdraw event, where no uni tokens were required because this function could be called with 0 amount. As a result, a user could continuously call this function, creating a potentially infinite number of events which could lead to an event log poisoning situation where malicious external users could spam the Unipool contract to generate arbitrary withdraw events. The recommendation was to consider adding a require or if statement to prevent the withdraw function from emitting the withdraw event when the amount variable was 0. This is related to validation of function parameters in 138 and auditing and logging in 173 of Security Pitfalls and Best Practices 201 module. 177 is a finding from OpenZeppelin's audit of Holdify, where the concern was about insufficient incentives to liquidators. For context, the liquidation process is a very important part of every DeFi project because it addresses the problem of a system being under-collateralized under critical conditions of the market, and therefore needs a design that incentivizes speed of liquidation execution. As per Holdify specification and implementation, the liquidators would end up paying for the expensive liquidation process without receiving any benefit other than buying potentially discounted collateral assets. The recommendation was to consider improving the incentive design to give liquidators higher incentives to execute the liquidation process. This is related to function invocation timeliness in 143 and incentive issues in 187 of Security Pitfalls and Best Practices 201 module. 178 is another finding from OpenZeppelin's audit of Holdify, where the concern was that markets could become insolvent. For context, when the value of all collateral is worth less than the value of all borrowed assets, a market is considered insolvent. The Holdify codebase could do many things to reduce the risk of market insolvency, such as selection of collateral ratios, incentivizing third-party collateral liquidation, careful selection of tokens listed on the platform, etc. However, the risk of insolvency would not be entirely eliminated, and there are numerous ways a market could still become insolvent. This risk is not unique to the Holdify project, and all collateralized loans, even non-blockchain ones, have a risk of insolvency. However, it was important to recognize that this risk does exist and that it could be difficult to recover from it. The recommendation was therefore to consider adding more targeted tests for insolvency scenarios to better understand the behavior of the protocol and designing relevant mechanics to make sure the platform operated properly under such conditions, and also consider communicating the potential risks to the users if needed. This is related to guarded launch via asset types in 129 and broader aspects of token handling in 159, system specification and documentation in 136, 137, and accounting issues in 171 of Security Pitfalls and Best Practices 201 module. 179 is another finding from OpenZeppelin's audit of Holdify, where the concern was that the project re-implemented some of OpenZeppelin's libraries and copied them as is in some others instead of importing the official ones. OpenZeppelin maintains a library of standard, audited, community-reviewed, and battle-tested smart contracts. Re-implementing or copying them increased the amount of code that the Holdify team would have to maintain and missed all the improvements and bug fixes that the OpenZeppelin team was constantly implementing with the help of the community. The recommendation was to consider importing the OpenZeppelin libraries instead of re-implementing or copying them, and further extend them where necessary to add extra functionalities. This is specifically related to cloning issues in 190 of Security Pitfalls and Best Practices 201 module. 180 is another finding from OpenZeppelin's audit of Holdify, where the concern was that there was a lack of indexed parameters in events. Throughout the Holdify's code base, none of the parameters in the events defined in the contracts were indexed. The recommendation was to consider indexing event parameters to facilitate off-chain services, searching and filtering for specific events, because recall that indexed event parameters are put into the topic part of the event log, which is faster to look up than the data part. This is specifically related to unindexed event parameters in 46 of Security Pitfalls and Best Practices 101 module, and broadly related to auditing logging issues in 173 of Security Pitfalls and Best Practices 201 module.